In this example, we want to solve the quadratic equation x squared plus 3x plus 3 equals 0. To get our solutions, or roots, we'll use the quadratic formula. This will give us that r1 and r2 are negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 3 all over 2 times 1. 3 squared is 9, and 4 times 1 times 3 is 12, and 2 times 1 is 2, so we get that our roots are negative 3 plus or minus the square root of 9 minus 12 over 2. And 9 minus 12 is negative 3, so we have negative 3 plus or minus the square root of negative 3 over 2. Now before, we would have stopped here and said that the square root of negative 3 is not a real number, so we have no real solutions. But now that we've understood complex numbers, we can take this further. The square root of negative 3 we can write as the square root of 3 times the square root of negative 1, which is the square root of 3 times I. So we get that the solutions to x squared plus 3x plus 3 equals 0 are the complex numbers negative 3 over 2 plus square root of 3 over 2i and negative 3 over 2 minus the square root of 3 over 2i. Notice the two solutions that we got are complex conjugates of each other. This is not a coincidence. The difference between the two solutions is the plus and minus before the imaginary part with I in our quadratic formula. So we can conclude that in general, if a plus bi is a solution to a quadratic equation, then its complex conjugate a minus bi is a solution as well.